Unit 6, Topic 3, Conditional Probability and Contingency Tables. Upon completion of this section, you should be able to use conditional probability notation to describe events and create and interpret contingency tables to find probability. A conditional probability is the likelihood that an event occurs given that the other event has already occurred. The conditional probability of A given B is written as the probability of A with that line there given B, where the line denotes given that. Example, suppose that you roll a die. Let E be the event that the die lands on an even number, and let A be the event that the die lands on 4. How would you represent the probability that the die lands on 4 given that it lands on an even number? Well, let's say that let me see how I could write that. You could say let E be even, and we'll just let 4 equal 4, which is pretty straightforward. So we would say, if we want to write probability that the die lands on 4, given that it's an even, we would say probability of 4 given even. All right, how would you represent the probability that the die lands on an even number, given that the die lands on 4? Well, that's pretty interesting. We would say probability that it's even, given that it lands on 4, well, that's going to be 100% or 1 because 4 is an even number. But we'll talk about that in a little bit. So that's pretty straightforward for how to notate it. And we'll talk a little bit as we go through some of these examples and the other problems. A contingency table provides a way of portraying data that can facilitate calculating probabilities. The table helps in determining conditional probabilities quite easily. The table displays sample values in relation to 2 different variables that may be dependent or contingent on one another. Use a contingency table to find probabilities. So here's a few notes. Given events A and B, to find probability at A, look for the total for event A and divide by the total number of outcomes in the sample space. Again, we'll be going through some examples that'll make this a little bit clearer. But first, we're just going to keep defining. Given events A and B, to find probability of A and B, look for the number at the intersection of A and B and divide the total number of outcomes in the sample space. Then given events A and B, to find probability of A given B, or when we have it here like this notation with the line, look for the number in the intersection of A and B and divide by the total number of outcomes in B. That's important. So this is A given B. So we're only considering if we know B is true, then what is the probability of A happening? All right. So here we would notate it like this. Probability of A given B equals the probability of A and B, that's that intersection, divided by the probability of B. So here's some examples of contingency tables. So we'll go through what I'm going to do. Hold on. All right, here's the table written out so we can go ahead and fill it in. So we're given these numbers. The example says the following incomplete table below shows a random sample of 155 high school students and if they prefer texting or calling. Well, let's be real honest. It's probably all texting. Definitely a little different than when I was in high school. All right, so what we need to do is fill in the blanks. So we know that these two need to add up to this, right? And we know that this whole column needs to add up to that 109, and this column needs to add up to that 46. Because what we're saying is then, is out of these numbers, we know we have 46 males and 109 females. We also know that we have 94 total that prefer texting. So first, let's start with here. It's kind of like a Sudoku a little bit. We know that the number of females that prefer texting is going to be 109 minus 47, right? So we have 109 minus 47 is going to give us 62 here. Now we know we have 2 unknowns here. So we know that 94 minus 62 is going to give us that males that prefer texting. 62 gives us 32. So now let's look at this column. We know that 32 plus something equals 46. So if we do 46 minus 32, we get 14. And then last, let's look at those who prefer calling. As we can tell, it's smaller. So 14 plus 47 gives us 61. And let's just double check that this total column here adds up. So we have 94 plus 61 does give us 155. So that's how you would fill all of those in. You know that these two, oops, I did not mean to erase that. These two need to add up to this. These two need to add up to this. Then we have these two need to add up to this. These two need to add up here. And then lastly, this column needs to add up here. And these two need to add up there. So that's how you fill it in, okay? So let's go down, see what else we've got. Those are all fill-in tables. So here's one, number 3 says the table below shows the number of athletes who stretched before exercising and how many had injuries within the past year. Part A says, what is the probability an athlete stretches before exercising at all? So if we're looking at that, this right here tells us the total number of people that stretch at all. We're not even worried about injuries at this point. We're literally just looking for what's the probability of stretching. So we would say that the probability of stretching at all equals 350 divided by the total, which is 800. And when we divide that, we get 0.4375. Now in this one, it doesn't tell us to round. It should tell you which decimal to round it to. So that would be the probability of stretching at all. Part B, that's part A. Part B says, find the probability that an athlete had no injury in the last year. So now instead of looking at these rows here for stretches, we're looking just for the column of no injury in the last year at all. So in this case, we're actually looking for this number right here, this 514 divided by 18. So the probability of no injury is going to equal 514, because again, that's the total number of athletes that were not injured, that did not have an injury in the last year. And this 800 is our total number of athletes in this survey. So 514 divided by 800. And when we do that, we get 0.6425. So we would say that the probability of not getting an injury is about 0.6425. All right, let's look at part C. So part C says, what is the probability an athlete stretches before exercise given they had no injury in the last year? So we're going to say, let's let A equal no injury. Oops. No injury. And we're going to let B equal, what did we say? Stretch. The athlete stretched. So now we're looking for the probability that an athlete stretches given. Probability they stretch given A. That means we're only considering the people that did not have an injury. So that means we're only looking at this column right here. We do not care about any of those that were injured. Well, we do care on a moral level, but we do not care about it for this probability. We don't care. We're only looking at this column. So that means that we're going to be dividing by 514 because that's all we're worried about at this point. And we're looking for the number or the probability of those that stretch. So we're looking for that 295. So we're saying, yeah, let's pretend like nothing else happened. We already know that they did not have an injury in the last year. Those are the only people we're worried about. What's the probability of those that they did not, or that they did stretch? So that 295 divided by 514, oops, equals 0.5739. So it's about 0.5739, that probability, which look at it. That's right, because it's a little over half. We have 295 out of 514. That is a little over half. Okay. So that's all the parts for that one. So that's kind of how you do some of the givens. Let's go ahead and do another one. Number 4, we have, suppose a study of speeding violations and drivers who use cell phones produce the following fictional data. So here we have uses cell phone and does not use cell phone. Here on this column is those that sped, they got a speeding violation. I shouldn't say those are sped. Those are the ones that actually got caught, speeding violation in the last year. And then no speeding violation in the last year. Wow, that's actually a pretty low percentage. I wonder where this fictional data came from. All right, find the probability a driver uses a cell phone while driving. So again, in this one, we don't have any givens, we don't have any ands. In this one, we are just looking at whether or not they use, what's the probability of them using a cell phone while they're driving. So right now, we know we're looking at the probability, I'm just gonna write cell, like uses their cell. So those that use a cell, the total number is all the way over here. 305 used a cell phone. And we're looking at the total number of drivers, which is 755. So when we do that on the calculator, we get point, and I'm going to round this to 4 decimal places. I'll round this to 3 decimal places. 404. So it's about 0.404, the probability that anybody uses a cell phone while they're driving. Part B says find the probability a driver had no violation in the last year. So now we're looking at columns, right? Because see here on this, the rows are for whether or not they use a cell phone. The columns are for the speeding violations. So we're looking for the probability. Again, we're going to write, I'm just going to write speed for speeding violation. Or this one says no violation, excuse me. So I'm going to write no speed. Oh, come on. So the no speeding is on this second column here. That's 685. And again, we're looking at the total number of drivers. There's no condition right here. We're looking at just the total number of drivers. So it looks like it's most of them. So we expect a very high probability here. So when we do that in the calculator, we get 0.907. 0.907. All right, let's look at part C. All right, so for part C, we have find the probability that a driver had no violation in the last year and was a cell phone user. Now, this one's a little different than the given, right? In the given, we're assuming that one thing is already known to be true. This is not the same thing. We're actually looking for the intersection and saying what's the probability that both of these things are true out of the total number of drivers. So here we're saying the probability that no violation, so no speed, and cell phone user. So where's that intersection? So here, this is the uses a cell phone. So we're going to go across till we find no speeding violation. And that's right here. So that equals 280 divided by the total. Again, it's not a given. If we were saying what's the probability that they used a cell phone given something, then we would be looking in a different area for the bottom number. But in this case, we're not. We want to know what's the probability that both these things are true out of the total number of drivers. So it's out of 755. So when we do that in the calculator, we get 0.3733. So that probability is about 0.3733. Let's look at part D, if I can write a D. Part D says find the probability a driver is a cell phone user given the driver had a violation in the last year. So we're saying probability that they are a cell phone user given that they had no violation. Or no, yeah, I'm just going to write no violation. So that means that we're only considering people in this no speeding violation. So that means our bottom number is going to be 685. And then we're looking for those that are a cell phone user. So that's going to be that 280. So we're going to do that. We get 280 divided by 685, and that gives us 0.4086 when we round it. So that probability is about 0.4086, which makes sense because it's a little less than half, right? All right, so I'm just about cut off for my 15-minute time limit, so I'm going to pick this up in part 2. We'll start with part E of this problem, all right?